Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm over at PDF Solutions with John Kibarian. Going to talk today about AI-driven collaboration in semiconductor manufacturing. John, what sort of problems are you starting to see, and what sort of changes are you starting to see as we start getting into much more complex chiplets and advanced packaging, multi-die assemblies?
Yeah, well, first of all, Ed, thank you for having me today. And our industry's big changes right now are 3D, 3D in the fab, 3D in packaging, much more diverse geographical regions for manufacturing going on around the world, and a very complex manufacturing flow when you think about not just the front end fab, but all the things that have to orchestrate in the packaging and test to get to now what are systems and package and systems that are built around those packages. So what we're seeing is customers wanting to leverage the industry that we're creating, the AI industry that we're creating as a chip industry, to take advantage of AI to get more efficient, more responsive, to be able to build more complex products quicker with lower cost and with higher manufacturing quality and yields. To do that, our customers are starting to realize it's not enough just to innovate in the AI algorithm itself, but they need to have an infrastructure to be able to deploy that at scale in our industry. And that, I think, is where we're seeing a lot of activity.
Let's take a closer look.
Sure.
John, what are we looking at?
What we're looking at is really kind of the three layers that we think the industry needs to deploy, the foundation layers to allow for AI-driven collaboration. When we look at our industry historically, the collaboration has primarily come from engineers and almost an event-based, like a bringing up a new product in a technology node, or in a crisis-driven situation where not being able to ship or not being able to yield, so we need to get everyone together to work on things. And now people come from different companies together, often on a weekly or daily or nightly Teams call to solve problems. In an AI-driven collaboration world, for the agent to work, we need to have underlying infrastructure possible. And that infrastructure really at the first layer is a secure data infrastructure, because when we look across our industry, very few companies do everything inside their four walls. They work with the supply chain, and they need to get access to data that's in that supply chain. It may be their data, may be the results of their test program, but it's at that supply chain.
That's been one of the big problems in sharing data, right? Everybody's always concerned that their data is going to be stolen or misused or lost.
Yes, it's always been a huge inhibitor. That's why often it's been event-driven collaboration. When there's a crisis, people are willing to share information because everyone's got to work to get things solved. What we saw really between the equipment industry and the foundries, really starting with the advent of EUV, collaboration needed to go on a daily basis. 7 nanometer technology is an awful lot like keeping a Formula One car on the racetrack. Whole pit crews need to work together. So SecureWISE, a company that we acquired earlier this year, put together an infrastructure that gave the factory the control of what data got shared with whom, by when, and how, the audit trail required, and the infrastructure in place to do that completely in an encrypted way off published internet addresses. So this gave the trust in the industry to partner and securely collaborate at a data layer. And that's the first step.
So once that first step's in place, now you can start doing things with that data that you couldn't do before, right?
Correct. And then at first, that was a lot of times humans, data getting transmitted, humans looking at that data and transmitting back information. But folks want to do that without necessarily the human in the loop. They want the human to establish the rules, to establish the boundary conditions, but then let an agent go off and do that work for them. And that's really where the orchestration came in. The orchestration really is a way of having systems to communicate with each other. Right? At one time, people thought, oh, I'm going to build a data lake and all my data is going to be in that data lake. Then they actually realized, well, wait a minute, to really deploy AI, I need not just the engineering data, but the financial data, the ERP data. I need the PLM information. I may need the MES information. And some of those systems may not reside inside my company, but are in other companies. Suppliers of mine may have the MES system about what tester on the test floor my part's going to be tested on. So that orchestration is a way of using a no-code or low-code way of having apps or agents communicate with each other about the information that resides in their lake houses, so they're able to operate and move more quickly.
And the industry is always really focused on latency. This is really latency of processes, right?
Correct. Correct. So if you just look at what's going on historically, a lot of times when someone in operations or manufacturing is stuck, right? Well, then it's an email out to the product test engineer at the equipment fabless company around what should I do about this or that, or maybe it's a Teams message or Slack channel or whatever. That's latent because now you're worrying about time zones. This person's asleep, that person's working. You lose a lot of time. When you bring agents into that process, you bring software and AI into that process. Now those things can communicate contemporaneously much more quickly, and that's really what orchestration enables.
Has the process latency been growing as we start adding more pieces into it? So think chiplets and different IP that's coming in from different places.
Yeah, it's a great point, Ed. So if you turn back and look at things, when everything was going on a monolithic IC, the number of steps was increasing. So, if it took 6 weeks to 2 months to process a 28 nanometer wafer, it's maybe 3 months plus. When you're looking at 2 nanometer, the number of steps has probably doubled, right? So the processing time has not doubled because the factories, the fabs have been super good about shrinking the time per process step, but the number of processing steps is growing so fast. Still, the overall cycle time increased. Now when you layer on top of that, I have a very complex advanced packaging flow that may also take weeks. Now you're looking at 4 to 6 months of time from wafer start to a completely packaged module out on the other end. And so this has grown tremendously. If you say 28 nanometer was maybe 2 months and then a couple weeks of package and test, to now maybe 4 to 6 months. It's really over doubling the time.
So the way the industry has always dealt with this has really been to abstract it up, right? And the problem now is you have so much data that you really have to abstract it up a level just to be able to understand what that data is all about.
Yeah, and then the question is, even at that higher level abstraction, who can understand it, really? And, I always joked about human limited learning. Humans are great at looking at 2 and 3D, maybe 4D. But when you start thinking about, a package that has 10 chiplets in it, each of which have 10,000 or 100,000 tests, you're looking at millions of parameters. So in a highly dimensioned space, it's very hard to just keep that all in your head. And so that's again where software really plays in to look at compressing that complexity down, extracting the information that's relevant, helping people see in a very high dimension space where the relevant control points are, and often doing all that online without the human involved so that the algorithms can move more quickly.
And this was the promise of AI for a while. Now we're getting into the agents. How does that help?
Yeah, so really what that enables, what the agents enables, the ability to go across functional areas, right? So I think, in the machine learning days, the earlier days of AI for manufacturing, it was get a data set, run a model, and then deploy that model in production. And that is going on and is moving out, there's no question about it. And as a result, it was often targeted to a specific functional area. So let's say you're an engineer responsible for preventative maintenance on a tool, you're going to look at the data for that tool and put in an ML model to be more adaptive and predicting. Or if I'm at test, I'm going to go and deploy a model to be smarter about test. But really what you're seeing customers wanting to do now is unlock the information that's in other data silos. The amount of information in design about where were the test slacks, what IP blocks were used, the PLM system knows what other IP is there. Using that information to make more informed production control decisions is really what agents allow you to do, really. And that's connecting up, again, using that orchestration layer to connect up much of the information that resides in other systems, so an algorithm can move more quickly and can do things you couldn't do previously.
John Kibarian, thanks for a really interesting look at what's going on across a very complicated supply chain.
Thanks, Ed. I appreciate your time.